So here's number 25 on the 1993 mechanics multiple choice test. It says a spring-loaded gun can fire a projectile to a height of h if it is fired straight up. If the same gun is pointed at an angle of 45 degrees from the vertical, what maximum height can now be reached by the projectile? And so, well, here's what we've got. Let's take a look at it like this. You fire it straight up, so it's going to have a velocity of v, and it's going to go up to some maximum height. So you can say that that the kinetic energy that it starts with, 1/2 mv squared, will be equal to all of the kinetic energy will turn into gravitational potential energy. And so that'll be mgh, so the mass cancels. And if you solve for h here, you're going to get v squared over 2g, right? I think that's right. Okay, so that's your maximum height. Now, if you fire this thing at a 45-degree angle, here's one way of looking at it. So here's the same velocity, but now it's at a 45-degree angle. I would look at it intuitively and say, look, I know that I'm still going to have kinetic energy when I'm at the so it's going to be like this, right? It's going to have some projectile motion like this, and I'm going to say, look, I'm still going to have now, kinetic energy is not a vector, it's a scalar, okay? But I'm thinking half of my kinetic energy is going to turn into gravitational potential energy, and the other half is still going to be kinetic. So if it's only got half as much kinetic energy turning into gravitational potential, it'll only go half as high. So that's going to give me an answer of C, okay, which is correct. Now, that's intuition. Okay, that's kind of a hand waving. Let's actually prove it here. We know here's the height here, but let's take a look at what our vertical velocity is right here. So here's my velocity v, but this is a 45-degree angle. So what is this velocity? What's the vertical component of the velocity? It's v, the hypotenuse, times √2/2, right? Or the sine of 45 degrees is √2/2. So this will give me the kinetic energy that's going to turn into gravitational potential energy. So I'll say that 1/2 m this v squared, and what is that? Well, that's v squared times 2/4, or 1/2, is equal to mgh. Now this h, I'll call this h prime. This is just to distinguish it from this h. This is the height it's going to go up at this 45-degree angle. So let's solve for h prime. H prime is going to be, well, let's take a look here. We've got the mass cancels, and I've got v squared over 2 times 2, 4g. And look, this h prime is going to be equal, well, v squared over 2g is h, so this would be h over 2. Think of this 4 as being 2 times 2. So this right here is your original h when you fired it straight up, and then you're dividing that in half. Oops, if I'm off screen, no, I'm not off screen. Okay, sorry. So there's how you solve number 25. That's why the answer is C. And so let's see, big picture wise, the big idea, conservation of energy, and that also velocity is a vector, and therefore it has components. And so if you're going straight up, it's only the vertical component of your velocity that, you know, the kinetic energy in that vertical component is going to turn into gravitational potential energy. So v sine theta. Okay, so anyway. So, oh, you also have to have memorized k equals 1/2 mv squared and u sub g equals mgh in a constant gravity field. So these are the things you have to have memorized in order to be able to solve this problem. Any questions on number 25? Yay, clapping. That is all.